Welcome to the Surgical Theater. Today, we're diving into this explainer to decode exactly what Cambridge examiners are looking for when it comes to one of the most notoriously tricky topics across the board, functions. Whether you're sitting for the 0580, 0606, 4024, 4037, 4040, or the rigorous 9709 syllabus, we are going to dissect past paper expectations with absolute surgical accuracy. Look, we aren't just looking at how to punch numbers into equations today. We are looking at the examiner's blueprint to understand the precise architecture of a perfect top-tier response. You need precision instruments and steady hands for this. It's about strategy, not just raw mathematical muscle. So, let's get scrubbed in and see how the top 1% actually tackle these papers.
This quote right here perfectly illustrates our core challenge. Mastering this specific syllabus area isn't just about your calculation power. The leap from a solid B to that coveted A-star requires pristine presentation, deep contextual awareness, and an absolute mastery of 5 interconnected components. Let me paint a picture for you. Think about 2 students sitting in the exam hall right now. Let's call them Alex and Sam. Alex overloads his paper with raw mathematics facts. He writes down every formula he can remember, vomiting numbers onto the page with zero analysis or structure. He thinks volume equals marks. Then there's Sam. Sam rushes. Sam completely misses the subtle command word requirements in the prompt, calculates a quick answer, and moves on. Both Alex and Sam are going to lose massive marks, even if their final numerical answer is technically correct. To get the A-star, you have to operate differently.
To reach that elite level, we'll be moving through a 4-part strategy today: core principles, technical methodology, critical analysis, and finally, those critical examiner warnings.
Let's start with Section 1, Core Principles.
Before we even look at the grading process, we've got to anchor ourselves to these precise syllabus definitions. Cambridge examiners view functions not as some isolated topic, but as a living, breathing web of interconnected concepts. You have to intuitively understand how a restricted domain actively dictates the range. You need to know exactly why a one-to-one relationship is the strict, non-negotiable prerequisite for an inverse function to even exist. And you must understand how composition layers these elements together like Russian nesting dolls of algebra. It's a system. Before we continue, subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE to excel in your Cambridge examinations. Click that subscribe button and hit the bell icon right now. Okay, so getting back to it, you must treat functions as an ecosystem where changing one variable inherently shifts everything else.
Under the high pressure of a timed exam, your brain does funny things. It is surprisingly easy to just completely drop one of these critical components when a heavy 8-mark question asks for a comprehensive analysis. So we're going to use a memory hack. DROIC, DROIC, Domain, Range, 1-1, Inverse Composition. Creating a quick mnemonic out of these first letters will help you instantly recall all 5 key terms. When you open that paper and see a high-mark functions question, I want you to mentally tick off DROIC to ensure your approach is completely exhaustive. Have you defined the domain? Have you checked the resulting range? Have you proven it's one-to-one using the horizontal line test? You get the idea. It's your ultimate pre-flight checklist.
Why does this exhaustive, systematic approach matter so much? Because the assessment objectives target these distinct cognitive domains in an exact hierarchical order. You must first demonstrate your raw knowledge. Then you must apply it. Finally, you reach analysis. To hit all 3 perfectly, top students use the Peel framework. Point, evidence, explanation, link. You make your mathematical point. You show your algebraic evidence, you give your explanation of the command words, and you link it back to the core question. You literally cannot skip straight to analysis without proving your foundational knowledge through that clear, structured application first.
This is a fascinating insight directly from the Principal Examiner Report. Examiners actively and enthusiastically reward students who integrate functions with other areas of the mathematics syllabus. This is where you decode the command words and apply them broadly. If you can show how a domain restriction impacts a complex trigonometry problem, or how a composite function behaves when you apply calculus to find a tangent, you are signaling a profound conceptual understanding that transfers to unfamiliar, highly complex contexts. That cross-pollination of mathematical ideas, that is exactly where the highest marks live. Moving right along to Section 2, Technical Methodology.
Now we're getting into the literal transformation of your exam paper. There's a massive gaping difference between an answer that bleeds easy marks and one that secures every single coveted method mark. Remember Alex from earlier? His paper is just messy, unstructured calculations. It looks like abstract art. And here's the brutal truth. A messy, rushed calculation, even if the final answer happens to be right, is a massive trap. If you make one tiny arithmetic error in a page of scattered scribbles, the examiner can't follow your logic, and you get a 0. Done. Instead, you need to rely on strict conventions. We're talking proper headings, correct terminology, structured Peel frameworks, and clear annotations. Display your procedural logic so brightly that the examiner has no choice but to award you those method marks along the way.
When facing complex data sources, like a highly detailed table of function values or a multi-layered graph, you must be highly, almost ruthlessly systematic. It's a three-step process. First, you sequentially extract the numbers from the texts and tables. Just get the raw data out. Next, interpret the underlying causal relationships between those numbers. Finally, draw purely evidence-based conclusions. Never, ever guess. Let the extracted data drive your final answer. Stop scrolling. Subscribe to our YouTube channel Ace the Exams at acetheexams_IGCSE to excel in your Cambridge examinations. We've helped thousands of students improve by 2-3 grade boundaries. Join them right now by subscribing to acetheexams_IGCSE and turn on all notifications so you never miss our weekly exam strategy sessions.
Let's step it up to Section 3, Critical Analysis.
Welcome to the interactive workshop portion of our session. I want you to actively engage with this. At this higher order level, you aren't just solving a given equation, you are critically evaluating it. You must operate seamlessly across descriptive, analytical, and evaluative levels to satisfy these demanding academic benchmarks. For example, if a question asks you to choose the most appropriate domain restriction to allow for an inverse function, you must evaluate the alternatives, compare why one approach works better than another, maybe algebraically, maybe graphically, and then justify your final recommendation with airtight mathematical proof. Imagine you're doing a data scan challenge right now. You've got 60 seconds on the clock to look at a complex chart and extract the core trend. It takes practice to spot the story the numbers are telling under that kind of pressure.
Now for our second challenge, finding the flaw. I want you to think about how Sam usually answers questions. Sam just lists isolated facts. Function A has a range of y greater than 0. Function B is a parabola. That flawed paragraph loses so many marks. True comparative analysis means supporting every point with evidence and explicitly drawing conclusions. You need to use comparative connectives to explicitly show exactly how function A's range serves as the domain for function B in a composite scenario. You have to identify both the similarities and the crucial differences. If you can spot the flaw in simply listing facts without connecting them, you are already thinking like a top-tier candidate.
Finally, Section 4, Examiner Warnings.
This is perhaps the most vital question of this entire explainer. Seriously, why do students who clearly know the material, who've memorized every single formula and identity, still lose easy marks? It is incredibly frustrating to know the math, but actually fail the specific parameters of the question. Think of our third challenge, speed writing. If you only had 30 seconds to write a perfect paragraph, you'd realize quickly that knowledge isn't enough. Execution is everything. So let's look at the actual hard data on student mistakes directly from Cambridge Examiner reports to see where the execution falls apart.
To build your ultimate time management matrix and answer system, you have to avoid the top 3 pitfalls. Number 1, forgetting proper format. We see this all the time when students define domains and ranges using sloppy, imprecise inequality notation. Number 2, failing to check presentation. This leads to ambiguous graphs or messy algebra that an examiner simply cannot follow, destroying your method marks. And number 3, providing answers that completely ignore the context of the question. You absolutely must avoid these specific pitfalls, especially the lack of proper formatting, which examiners red flag year after year after year.
Let me emphasize this with a massive flashing examiner alert. The absolute classic mistake, the one that drives examiners crazy, is providing generic answers. Let's say a question presents a real-world scenario modeled by a function, like the cooling rate of a chemical compound over time. If you simply write down a memorized generic algebraic property without actively applying it to that exact chemical scenario described, you will lose the mark, period. The examiner wants to see that you understand what the math actually represents in the physical universe of that specific question. Generic answers are the enemy of the A-star.
Which brings us to the ultimate golden rule. I want you to burn this rule into your memory right now. Your structured reasoning must always directly tie back to the specific problem at hand. Whether you're finding an inverse or mapping a highly complex composite function, explicitly state how your mathematical conclusion answers the prompt. Students who implement these mathematics strategies see an average improvement of 2 grade boundaries, but only if they practice consistently with our weekly videos. Here's your final reminder.
Subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE to excel in your Cambridge examinations. Subscribe right now to at acetheexams_IGCSE and click that bell. Don't let another exam pass you by.
We have completely decoded the core concepts of DROIC, the necessity of strict technical methodology, the power of critical analysis, and the traps that catch out unprepared students. We've given you the tools to avoid being an Alex or a Sam. So, I leave you with this final provocative thought. In your very next past paper, will you be the student who simply relies on messy, raw mathematical calculation, or will you be the strategic architect who bends the examiner's blueprint to your absolute advantage? Drop a comment below with your target grade for mathematics and the biggest challenge you're facing. Our team responds to every comment. Like and share this video with a study partner. Ace the Exams. Your Cambridge success starts here.